Welcome back. Happy Wednesday. We're going to keep going. Lesson 65, distinguishing types of parallelograms. All right, if you remember just a few days ago, probably the end of last week, we talked about determining if a quadrilateral was a parallelogram. Okay, we found some different ways, different properties that we could use to determine that, if a quadrilateral really was a parallelogram. Okay. Going forward now, we're going to decide if we can decide if the parallelogram is not just a parallelogram, but is it a rectangle, a rhombus, or a square? Rectangle, rhombus, or a square. Okay? Do you remember there were some things that we decided what made a rectangle a rectangle? What was special about a rectangle? Okay? Now, granted, all of these are parallelograms, so yes, the first thing I could write for all of these are parallelogram. But I'm not going to because we've already decided that they are. So, parallelogram, what makes it a rectangle? What was special about that? That's right, it has 4 right angles. If it had 4 right angles, then it was a rectangle. It could have also been a square, but it didn't have to be. Okay? Was there anything else about a rectangle that you remember about properties of rectangles, rhombuses, and squares? Okay? There should be one more for sure. It was about the diagonals. Okay, if you remember, you're looking back. The diagonals actually are congruent. Okay, the diagonals are congruent. Okay, those are our 2 pieces for a rectangle. What about a rhombus? What made a rhombus a rhombus? Okay, parallelogram, yes, but it has 4 congruent sides. All the side lengths are congruent. Yes. There were actually, for a rhombus, there were 2 things about the diagonals that we need to remember. So let's go. Diagonals, what? Bisect each other are for all parallelograms. The diagonals are perpendicular. Okay? Put a little perpendicular. Okay? One more thing about the diagonals. The diagonals actually bisect each angle. Okay? So actually I want to draw what this might look like for both of these. We're going to start with a rectangle. This is me drawing, so it's not going to be perfect, I know. Let's undo that. We'll try to do a little bit better. Okay, so we have right angles, and the diagonals will be congruent to each other. So every piece here, diagonals bisect, so that's true for every parallelogram, but if they're congruent, all 4 of those segments will be congruent. Okay? For a rhombus, okay, all 4 sides are congruent. Okay? If I draw the diagonals, they are perpendicular. And the angles bisect. I'm going to do a little different color. So this angle and this angle are congruent to this angle and this angle. Okay? And this angle and this angle are congruent to each other and to each of these angles down here. Okay? Those are properties we already know about rectangles, rhombuses, and squares. Wait, Miss Evans, you didn't talk at all about squares. Because what is special about a square? How could we prove something was a square? We would have to prove it is a rectangle and a rhombus. Oh, Miss Evans, you said that prove word. Yes, we're going to have to do a little bit of proving for this lesson. So, these are things we already know. In the boxes, the properties of parallelograms, those are not theorems. They're not postulates. They're not theorems. That's not where they go, okay? But they are properties, so we need to have them in our notes. It says, if an angle is a parallelogram, in a parallelogram is a right angle, then the parallelogram is a rectangle. We only have to know one angle is a right angle. Then it has to be a rectangle. Well, why is that? Because opposite angles in a parallelogram are congruent. So that means this would be a right angle. And consecutive angles, the angles next to each other, are supplementary. So if this is 90 degrees, then this would be 90 degrees. Henceforth, they're all for 90 degrees. Okay, we only have to know one. Okay? If consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So all you have to know are two consecutive. Consecutive just means beside each other. Two side lengths beside each other are congruent in a parallelogram, then it must be a rhombus. Now, question, if you had one right angle, meaning it's a rectangle, and consecutive sides that are congruent, what would we have? We would have a rectangle and a rhombus, which would mean it is a square. That's correct. Okay. Next property. If the diagonals of a parallelogram are congruent, then it is a rectangle. We have that property. If the diagonals of a parallelogram are perpendicular, then it is a rhombus. Okay, last one. There's one on the next page. If a diagonal in a parallelogram bisects opposite angles, then it is a rhombus. Okay? So in this lesson, we're really just going to be saying what type of shape is it? Okay? There are some different pieces that I want to look at. Okay, let me draw an actual something like a rectangle. Okay? And I'm going to draw the diagonals. I'm going to pretend they're going to hit here. Still not 100% calibrated. Imagine that. Okay, let me give it a name. They give the name math. M-A-T-H. They do have somewhat of a sense of humor. Okay, and it tells me that this length right here is 45.5 minus 3n. This side right here is 4n plus 14. This side is 4n plus 14. And this side is 45.5 minus 3n. Can you tell me what's the value of n? What value of n makes M-A-T-H a rectangle? Sorry, I have extra little handwritings on my board, extra marks. So, you might have noticed that this length and this length have the exact same expression, 45.5 minus 3n. They have to be the same. Why? It's a parallelogram, okay? So they have to be. But now they're asking, and if I set them equal to each other, I really have 0 equals 0, so I can't just solve for n that way. But if we go back to the third property, as if the diagonals of a parallelogram are congruent, then it's a rectangle. What I really need to know is this equal to this, okay? Or we could just add them together and have the whole thing equal. So we could add these two and set them equal to these two, okay? Either way, it shouldn't matter which way we do it, okay? So I am going to do 4n plus 14 equals 45.5 minus 3n. If I solve for n, because it says what value of n, so it means I need to solve for n. So I'm going to add 3n to both sides. I get a 7n over here. I'm going to go ahead and subtract 14. That's okay. We're going to move a little bit quicker. These are going to cancel. 7n equals 31.5. Right? Now if I divide both sides by 7, I'm going to think about my calculator for just a second. Of course, I didn't make this up. 7 goes into 31 at least 4 times. It should come out nice and easy. If n equals 4.5, then MATH is a rectangle. Okay? All right. If I gave you another one where, here we go. Let me do another one. Let me kind of change it up a little bit. I'm going to name this one normal, A, B, C, D. And I'm going to draw the triangles. I tell you that this side is parallel to this, and this side is parallel to this. So I tell you it's a parallelogram. And I tell you a few side lengths. I tell you that A to B is 35. A to E, I put an E in the middle. A to E is 28. And B to E is 21. And I'm asking you, what type of parallelogram is this? Okay. Question, could you tell really quick, is it a rectangle? This 28 and this 21 should tell you it is not a rectangle. Okay? Because 21 does not equal 28. Okay? Well, that means it's not anything. Well, what about a rhombus? What do we know about the diagonals of a rhombus? That's right, they are perpendicular side lengths. So what could we do about just this little triangle right here? Let's change colors so it stands out. Triangle ABE. Could we find out what type of triangle ABE is? Is what type of triangle? Question mark. All right, so could we say 21 squared plus 28 squared? Really, I'm checking to see, is it a right triangle? So what is 21 squared? I don't know. I have to pull up my calculator. Sorry about that. Woo. If you're just seeing this, I'm sorry. So 21 squared plus 28 squared. I have real calculators at my house. And I'm going to see, does that equal 35 squared? It does. 1, 2, 2, 5 equals 1, 2, 2, 5. It is a right triangle. So what do we know about the angle BEA? We know it is a right triangle. We would say it is a rhombus because the angle BEA is a right triangle? This is a rhombus. Because angle BEA is a right angle. And diagonals are perpendicular. But this one would say, give me an explain. So it might say explain. Diagonals are perpendicular in a rhombus. And you're good. Perfect. So that one might have a little bit, what type of parallelogram is it? And explain how you know. So it's a rhombus because this. All right, some problems for today. Lesson 65. Homework. We're going to do the practice. I think we can do all of the practice. A through F. And we're simply going to do number 1 and number 2. Okay, we'll have a homework quiz on Friday. Please email me or message me, and here send me a message, a comment about if you have any questions on any of the homeworks we've had so far. Okay, I want to make sure that you've got all that in case we need to talk more about any of them. All right, happy Wednesday. It's hump day, so I will see you again tomorrow. Bye.